This lesson is going to be about potential energy calculations, and the learning target is to be able to make calculations of gravitational potential energy. So when we look at potential energy, there's a specific formula for this one, and it is PE equals mgh, and the PE stands for potential energy. That's what we're going to be calculating. And this is in joules. So we're going to add this unit in here. This is calculated in joules, capital J here. We've got our M, which is our mass, and that's going to be in kilograms. Right? So when we're plugging in masses, we've got to make sure that they're in kilograms here. G is going to be our acceleration due to gravity. Remember that all objects accelerate down to Earth at the same rate. If we have two different sized masses, so let's say we took mass number 1 and it was 5 kilograms, and we took mass number 2, which was, I don't know, 100 kilograms, they both accelerate down to the Earth at the same rate. Now, they have different forces acting on them. 100 kilograms has more force acting on it from gravity, gravitational force. But because its inertia is so much higher, they balance out and they accelerate down at the same rate. And so all objects accelerate at a rate of 9.8 meters per second squared. And so when we're calculating potential energy, that's the number we're going to use for our acceleration due to gravity. And then h is going to tell us our height, and that's measured in meters above the ground. Remember, we're staying in metric, so we're measuring in meters here. So we're going to get some chances to use this equation here. So if we look at some problems, we have how much gravitational potential energy does a 100 kilogram person have if they are standing on a chair 0.5 meters high? So what we'd start off with is we know that we're looking for our gravitational potential energy. And so I'm going to start off with my PE equals mgh, my mass, my acceleration due to gravity, and my height. And I can look through my problem and I see that I have 100 kilograms. Well, I know that that's my mass. So I have mass equals 100 kilograms. And I can look through the problem some more and find some more numbers here. And I have my height is 0.5 meters. And I'm looking and I don't have my acceleration due to gravity in the problem because it is always going to be the same, 9.8 meters per second squared. And so now I can punch in these numbers into this equation. I can see PE equals my 100 kilograms, my mass. I know that I have 9.8 meters per second squared, and I know that my height is 0.5 meters. And so then I calculate that out, multiply them all together, and I get a potential energy of 490 joules, which would be my answer to this problem. So we have another problem here. A 4 kilogram book is held 1.5 meters above the floor. How much gravitational potential energy does it have? So we're looking for gravitational potential energy in this one. I have PE equals my mgh. My mass here, we're looking for kilograms. A 4 kilogram book, 4 kg. I know that my g here is 9.8 meters per second squared. And I know that my height that I'm looking for is going to be in meters. So I know that my height is 1.5 meters. And so now I can just plug all these into my equation. So I have PE equals 4 kilograms. I have my 9.8 meters per second squared. And my height is 1.5 meters. And so I multiply all of those together to get my potential energy. 58.8 joules would be my answer here. And I know that it's in joules because the units for energy are in joules. We just keep that capital J. And so this would be the answer to this problem. So we're looking at a different one here. A monkey swinging from a branch of a tree suddenly sees a tiger below and swings up to a higher branch for safety. When he swings down to the higher branch, his potential energy increases by 215 joules. If the monkey's mass is 6.5 kilograms, what is the change in height of the monkey? And so this one we're going to look first. What are we trying to find? We're looking for the change in height. And so we're going to try to find our h variable in here. So we start off with our mgh. Now, if you're feeling pretty comfortable with algebra, what you would do here is we're trying to get this h by itself. And so if I think back to what I have to do for math class to get this, I would take and I would divide both sides by g, or mg, divide both sides by mg. These ones cancel out, and what I'm left with is PE over mg would equal my height. If you weren't comfortable with that, the same thing also goes for the equation triangle that we've used before. So we have PE to start with, we have M, we have G, and we have H are all parts of that. This equation triangle kind of helps with the algebra, and you would use it the same way, where if I wanted to find H, I would just cover up my H, and I would be left with PE divided by mg, m times g. Remember, if things are on the same level of this equation triangle, we're going to multiply them. And if something is at the top, like our PE, then we would take that and divide it by the other variables in here. And so once we have our equation, we're looking for our h, our height. Now we can look and see what we have to plug some of these numbers in. Oops. So I can look and see, okay, well, where's my potential energy? Well, I have my potential energy increases by 215. So I'm going to say PE equals 215 joules. I can also look and try to find my mass. So I've got 6.5 kilograms. And my G is always going to be the same, and that's 9.8 meters per second squared. So now I have all the different factors that I need to get my height. And so I would plug in, I'm going to do this so it's not backwards here. I know we always read left to right, so it gets hard to do it the other way. H equals my potential energy on top, which is 215 joules, divided by my mass, which is 6.5 kilograms, and my acceleration due to gravity, which is 9.8 meters per second squared. So I would take my 215, and I would divide by my 6.5, and then I would divide by my 9.8, and I would end up with an answer of a height of 3.3 meters. That's what that monkey swung up to. So that would be the way to get the answer for this one, using the same equation for potential energy, just manipulating the variables, so we're getting different answers here. So another problem here, we've got a potted plant sits on the shelf of a flower store where it has 150 joules of gravitational potential energy relative to the floor. If the plant is 2.5 meters above the floor, what is the mass of the plant? And so when I look through this problem, I'm going to be trying to find the mass. What is the mass of the plant? So I don't know my mass, but I do know that my potential energy equals mass times the acceleration due to gravity times the height of this object. And so what I can do here is I know that I got to get my mass by itself, and so I can take and divide both sides by g and h, my acceleration due to gravity, and my height. They cancel out. Oops, not canceling my mass. I would cancel my gravity and my height, and I'm left with my mass. And what I get is PE divided by GH, you get the picture, equals EM. And so this equation is going to help me to find my mass. And so now I can look through my problem and see what I have. I have my potential energy, which is right here, 150 newtons of gravitational potential energy. PE equals 150 joules. I have my height, which is 2.5 meters, and I know that my acceleration due to gravity is always 9.8 meters per second squared. So now I can plug into my equation. Again, we're going to flip things so they're left to right. Potential energy, whoops, we're actually going to plug these numbers in. So we go 150 joules divided by my gravitational acceleration, 9.8 meters per second squared. And then I have my height, which is 2.5 meters. And if I take 150, divide by 9.8, and then divide by 2.5, plug this all into my calculator, I get a mass of 6.1 kilograms of that plant. And so that would be the answer to my problem. And so whenever we're doing these problems, we know what our equation is. PE equals mgh. Mass is in kilograms. We've got G is gravitational acceleration, 9.8 meters per second squared. Always the same as long as you're on Earth. And then we have our height, which is the the height in meters. And so I hope this video helps you to make some calculations using potential energy.